Hey y'all, CB here at NBS Welding. Got a service rig in here doing some repairs to the aluminum canopy over the rig. So take a look at what we got here. Believe it or not, all of that top section right there, even though it looks black and nasty, is aluminum. Covered in grease and all kinds of filthy things, hydrocarbons from hell. And this being aluminum, the company that owns it doesn't have a way to weld aluminum. So as it's broke, which aluminum does because it's weak, you know, they've done things what they could to try and repair it with steel. They've screwed and bolted pieces of steel on it. There's a bracket right here. They had a piece of angle iron and those bolts right there, and they had it bolted on right here. That's 1.5 inches by 1.5 inches, 1/8 inch wall aluminum square tube, that leg right there. So I'll show you a little bit more about the situation with that leg. Hang on here a second. Got that angle iron bracket removed, and there's our leg. So we see that's been broke for a while. Really contaminated stuff. It's going to take a lot of wire brushing to get this stuff where it can be dealt with. Things that need cleaned up, pulled together, and welded. Well, here's the setup. We're plugged into the 240 volt current shop with the adapter that I've got made. And that takes us to this 220 volt power box right here, where I've got this 12 gauge cord plugged in. That's a 100-foot 12 gauge cord. And that brings us out here to the ARCCAPTAIN MIG 200, which I've got my spool gun on. Got the spool gun on the MIG 200. And I've done a lot of cleanup, power brushing. Actually had to start out power washing. This rig was just filthy. I got a couple tacks on here, and I'm going to pull this thing around straight, get her welded up. Just cut out a gusset. I took a bunch of pieces of aluminum out of my scrap. A lot of them were bending mistakes, things that I bent in the brake. And this is one of the pieces. I just cut that out and made a gusset. And I found other pieces that were bent, and I just cut and cleaned up a bunch of these angles. These would be different things I can use for bracing on this. These are aluminum parts that I bent in the brake and didn't work for whatever I was using them for, so it's stuff I can cut up and use to brace up this rig. Having trouble with the wind blowing. This service rig's too big to get in the shop, and so one of the things I'm doing is I've put up a tarp, and I'll have to you know, do whatever I got to do to get the wind away, get the wind off, so that it doesn't blow my argon shield gas away. If you're going to MIG weld aluminum, you got to have that shield gas blowing on your weld, and if it's too windy, it'll mess you up. So we're going to keep going with this. Got that tarp out of the way. I had that MiG 200 setting. This is how light this machine is. Just sitting there on the brace of that ladder. Let's take a look at this repair we got on this leg. It's all done. There's other legs to fix and other things to do, but this one's done. This has this bracket. You know, these two brackets right here welded on, and so that the roof can be bolted to this post. It's the way that's made. And then right here is where it was broken completely off, and I sanded this a little bit because this plate gets bolted up against there. That plate doesn't get welded. I added this gusset right here, and this is one of those angle braces right here. So it's braced up pretty good there in the area where it broke off. You know, it broke off right at the top of this. Where this angle come across, that was snapped right off right there. So we got that gusset on the inside and then this angle brace on the outside. So that should help all that. Did have one little fire. Now these rigs, no matter how much you wash on them, they're greasy pigs. A lot of grease, and they're out in the woods. You get a lot of places in these rigs where twigs and leaves and stuff will lay, and they get, you know, that tinder gets soaked in oil and grease, and it's one of the things you really got to be concerned about when you're welding on a machine like this. If you get this thing burning, she's a goner. You know, like I say, you can power wash on one of these things till you're blue in the face, but you still got, basically all you're doing when you're power washing is you're blowing the grease off of one side onto the other. You know, you go to the other side of it and power wash, and you just blow the grease and oil back the other way. To get it all off there, it's just almost impossible. And like I say, you really got to be concerned about the places where you've got leaves and twigs and stuff. I had a little pile of leaves and twigs that was coated in oil that caught fire while I was welding on this, and that's something you got to watch. You know, get that put out before it gets out of control. That was something I was able to put out with my glove, you know, and that's when you want to put it out. If it goes past that, then you need to hit it with a fire extinguisher. You know, when you get to the point where, you know, if you let something like this get caught where your fire extinguisher won't do it, she's a goner, man. You don't want to be the guy that burned the rig down. So the next thing on this is going to be cleaning up and putting a few things away so I'm not tripping over my tools while I'm reassembling this and bolting it back together the way it was. And the other thing's going to be just basically fire watching this thing for 20 or 30 minutes before I walk away from it this evening, because I want to make sure nothing sparks up. So fire watch is the thing. You know, you can have something smoldering and you know, you got to make sure that that's not going to be a problem. So we'll put this thing back together and make sure we don't have any fires, and then we'll see what's next on the plan. Got that done and was looking at what's next, and I just happened to notice when I look down here at this tube, that tube down at the bottom's got a bit of a rounded look to it. I bet that tube's full of water. When this has been damaged, where this is broke, while that was broke, water's gotten down inside there. Now, the reason that's bulged out is water's gotten inside that tube and it's frozen, expanded. When water does that, it can break about anything. I've actually seen 4x4 3/8 wall steel tubes busted wide open by ice. That stuff, when it expands, it's really that strong. So if you run into a situation where water's gotten into a tube like that, you got to let it out. Yep. Over here on the other side of this rig, this is another one of the posts that it's just broken clear off. And I was about to put that back together, put my plate back together. And I'm realizing I don't want to do that yet because I might need it apart for this. Now this guard right here, I can pull it away a little bit, but I need to get that guard out of the way. This post, this outer post, looks pretty good. Instead of having 2 aluminum brackets, they've got 1 piece of steel angle iron bolted there. But to bolt the roof on, I think that's as good a way as any for that to be. So that's so solid right there. I'm not gonna mess with that, but this is something needs done here. Let me see if I can get this guard out of the way and part of this mud flap, and we'll go from there. Well, I had doubts if I could make enough space in there to work for a while, but obviously now I can see. I got some bolts out of that thing, and I got the old leg jerked out of there. Where I took this bolt out right here, this plate came back far enough, and I jammed that piece of angle iron in there. I can reach around that to weld that leg back on there. And then, you know, if I do that, then I could put a gusset like I did over there. which would help a lot. And I think that's probably what I'm going to do right here. You can see I can reach in there and do a lot more than I thought I could now that I got that guard out of there and unbolted that plate and spread that apart. It's not going to be easy to weld on this side, but it looks like I could reach the rest of it all right. These things ain't easy to work on no matter what you do. But then I'll have to come up with something that bolts the tube to the top. You know, the legs aren't welded. The legs aren't welded to the roof. And like they did here where they put a steel clip, that's really not a bad idea. I might do something like that on that other post there. But yeah, we'll get it welded on there first, and then we'll figure out how we're going to bolt it together at the top and bolt it to the roof. The grease and the filth and the rust and contamination wasn't enough to cause us trouble fixing this aluminum rig canopy, so we got weather, rain on top of that. Here's the setup. I picked up my everything I need. I had on the table, on the welding table, and I picked it up with a forklift and carried it over here. It gives me a platform to stand on. I got a jack stand under it so it's not wobbly, but the forklift's basically holding it. The MiG 200 and all the grinders and everything, the tank for the argon, it's all set up on the table, and the table gives me a little bit better place to stand. Right here, got a lot of power brushing done and stuff cleaned up. This is the area right here where I'm going to be bolting whatever kind of a plate I bolt onto this leg when we get the leg welded back in. And I noticed when there was some kind of a little aluminum something welded right here. And I don't know what it was. It definitely wasn't something being used. But I cut that off because I'm going to be... This is one of the bolt holes right here where that bolt goes to hold that mud flap in place. And that would be a good bolt and bolt hole to go ahead and use to hold this leg. But down here at the bottom, the leg will be getting welded. So that's our task right now, is everything we got cleaned up here is to get that leg welded on and get it braced. Weld it on there, and we'll probably run a gusset similar to the other one. And then we'll figure out how to fabricate some sort of a plate for the bolt connection that holds the roof onto the post. Got that welded up and put that gusset in there, welded it up. I sanded off the back there so it'll be flat. This is in there a little bit, but this, I can pull that out flush with this where it belongs. Don't worry about that. So now it's going to be some reassembly. Before I make this piece, I'm going to bolt this plate back to this aluminum frame, and you know, all this will come back together. There's a few bolts I got to stick in it, and I'll do that before I make this piece right here. Got the bracket made that's going to bolt this post onto the roof here. And right here's the best look we'll ever get at it, because I got to put that mud flap back. And once it's back there, this bracket will really be covered up. You'd never know it was there. But those mud flaps, they look like they're getting tattered. They do need replaced. But I'm seeing how that's probably a really good thing to have on there, because you get a lot of grease and stuff slinging off of this drum, and you don't want that in here on your deck motor and everything. But yeah, so I had this bolt in there temporarily to get positioning right, but I can take that bolt back out and I can put the mud flaps back, and then we'll be moving on. Well, alrighty then. Got her all put back together. Got the mud flaps put back in place and put that guard back on there. So that's all buttoned up and done. We're going to be moving around to the other side and doing some more aluminum repairs over there. I want to mention real quick, I'm enjoying the spool gun on the ARCCAPTAIN MIG 200. This thing's just, you know, if you follow the channel, you've probably seen me out here carrying my my Millermatic 252 with a spool gun, carrying it around with a forklift, welding on the side of stuff outside of here. It can be a hassle. That great big 252, this ARCCAPTAIN MIG 200 is doing the job, and it's just so tiny. And it's nice. I got it throwed up here on the table. I got my tank and spool gun and everything on the table, and I can drive around with a forklift. But another thing I'll mention on these dual voltage machines, I think some of them come with a 220 plug on them. And then they give you an adapter to run it on 110. My ARCCAPTAIN MIG 200 came with the 110 plug and an adapter to run it off of 220, which I ended up making up my own adapter. And I had to make my own adapter because of the outlets I use. They're a little bit different. I use a NEMA 1450, which is the same 220, 240 volt outlet that is on my weld machines. If I want to plug one of my electric machines into my engine drives have a 240 volt outlet that's that NEMA 1450. So I made an adapter that goes from the NEMA 1450 240 volt plug of mine to you know, a regular 120. And because of that, I would prefer any dual voltage machine to have the 120 volt plug. I don't want it to have a 220 plug. And I know they sell these machines all over the world, and it, you know, different places you're gonna run into different stuff. But I think any dual voltage machine in the United States, you'd be better off having the 110 plug like this on it, and then an adapter for 220. And the reason I say that is, one thing is, that would mean that anywhere you went where there was power, you know, you could plug it in. Even if you could only run it on 110, you could run it. If it's got a 220 plug on it and you forgot your adapter or something, or you had the wrong adapter, you'd show up somewhere and go to plug it in and you wouldn't be able to plug it in. Anywhere in the U.S. that there's power, there's going to be a place to plug this in, at least for 110 or 120 volt. And then, you know, there's so many different 220 outlets that, you know, when you do go to 220, you're going to want whatever adapter you need. and maybe an assortment of them. You might have to have a bunch of different ones. Another thing that I think is a huge advantage to using the 110 plug on your machine is you can do like I've done here. I'm using an extension cord, a 100-foot 12-gauge extension cord. That's an extension cord for 110 stuff. Well, see, now I have a 220 extension cord that's great big heavy 8 or 10 gauge cord. But most people, may not have that. And it's more likely that you would have an extension cord that was the 120 volt, 110 volt type than it would be a great big 220. And if you've got this plug on your machine and you got an adapter for your 220, then you can run a regular 110 extension cord in between there if you got a good heavy one. I've been running this off a 12 gauge that's 100 foot long and had no problems whatsoever. So what I've got is, like I showed you before, I've got my 220 adapter plugged into the wall in there on the 220. And then I've got that 100-foot cord, which is a 120 plug cord, plugged into the adapter. And then I got my ARCCAPTAIN MIG 200 plugged into that cord. And if you do have a dual voltage machine that has a 220 plug on it instead of the 110, if you want it like this, it's not hard to change it, Go to the hardware store and get you a heavy duty plug and make up whatever you need. But just wanted to mention that real quick because I like it with the 120 myself, and I'm real happy with the MiG 200 and the spool gun here. And we're gonna move over to the other side and do some more aluminum repair. That's not supposed to be like that. Yeah, we got a little coming apartage here. Several welds broke on the top of that. I don't know exactly what kind of force it's going to take to pull this back together. I'm going to start with a ratchet strap. If that pulls it together, then we're getting somewhere. It may take something a lot bigger. I might have to get into, come along or something like that, but see what I can do with a ratchet strap. That pulled together fine with that ratchet strap. Got the end welded where it was broke. Got this welded, and what we had pretty much across the top, there was these 4 pretty big stitch welds that I ended up cutting out, you know, and replacing with new welds. And I ran, they had just like one pass. I ran some extra on it. It's a service rig, a little extra weld ain't gonna hurt it. And then the other thing I saw when I was in this area, that bracket's broke right there. So I'm gonna cut that. I'm gonna cut all that weld out and re-weld it too. I took my wheel that I always cut the aluminum welds out with, the old Hercules death wheel, and I cut a broken weld out right there on that one. And I'll tell you what happened is that's been repaired before, and when I cut all that old weld out, it was gouged up in behind there really bad. So somebody really melted the hell out of that bracket at some point, and they barely got it welded, and they probably had to do it. They melted it so bad they had to do it real cold. That's the reason it's like this, because I actually ended up taking it off and flipping it over. And I used my sander to round off this part that was melted off. This was up there where they were actually welding on it. I used my sander to round off the melted part to try to make it look like it was supposed to be that way, but this is actually upside down from the way it was. But the way I flipped it over, it gave me new metal to weld on, new aluminum to, you know, to put my weld on, which that worked out. So we got that, and we got that. And I noticed this lift eye is in pretty bad shape. It's been hit with something. I'm sure these really thin lift eyes have just been put on here as a way to put this roof on or take the roof off or whatever. So I wouldn't count on this to be something that's got to hold a lot of weight. These roofs don't weigh much. And there's a risk in trying to fix this because you might break it. But the thing I'm seeing, this looks terrible. And it looks so bad, why not try to fix it? You know, I mean, we can straighten it out, break it off, whatever we do, it's not going to look worse than it looks right now. So I'm going to try to straighten it out some. So that's one of the things where, you know, obviously it's not perfect, but man, it's way better than it was. And when I was bending on it, you might have seen a little crack formed right there at the corner. It was trying to tear that weld. So I ran a little bit of weld on it, reinforced that, and we're going to call that good enough. Like I say, I think those are just there to lift the roof. And I don't know, it's better than it was. That's good enough. I'm not going to waste any more time on that. Next thing I'm wanting to look at, up underneath here is a broken place. And what they've done, you see where they screwed on, it looks like they used some self-tapping screws and screwed a piece of steel on here because that tubing, the welds on that tubing broke. I'm going to see if I can take those screws off and take a look at this. Came over here to the super service truck to get some different tools because we got a situation over there on that aluminum weld that's broke. Up underneath of that roof, there's some parts of it where my regular angle grinder tools aren't going to do us any good. On the very bottom where the welds on those square tubes are broke, you know, I can use my regular angle grinder tools for that. And if you've paid attention to me mentioning the angle grinders I usually use for aluminum, these are a lower RPM angle grinder. They don't turn 10,000 RPM. They turn slower, and I use stainless steel wire brushes, and I use that death wheel, the metal cutter wheel, and I use it on a lower RPM tool when I'm doing aluminum. There's another thing that's specific to aluminum in this situation where your angle grinder tool is not going to work. You're going to have to get in there with a carbide burr. If you got in a situation where you're going to have to use one of these end grinders and go in there with a carbide burr, I want you to look at the difference in these carbides right here. Now the one on the right with teeth close together, that's what you want when you're doing this on steel. But these will not work very good at all on aluminum. On aluminum, you need a carbide burr like this. See how the gaps between the cutters are so much bigger? If you try to run one of these ones for steel on aluminum, it'll just galled up with aluminum and you're done. It just doesn't work. And I tell you, every time I mention this, and I appreciate every comment I get, good, bad, or indifferent. Give me a negative comment. I'd rather have a negative comment than no comment. But I just tell you, every time I mention the carbide burrs and talk about it on the channel, and also a lot of times with aluminum, I mention how I use beeswax on my sanding pads. When I apply beeswax to my sanding pads on my sander, on my angle grinder, that keeps the aluminum from galled up in my sanding pads. And when I mention aluminum getting galled up on these burrs or aluminum getting galled up on the sanding pads and using the beeswax, it's almost always there's somebody that says put WD-40 on it. And if your application allows that and it works for you, great. But I'm telling you, if you're going to weld it, don't put oil on it. Don't contaminate aluminum that you're about to weld with oil. We're trying to remove contaminations that will cause issues with welding. We're not trying to apply them. And you really got to be careful with aluminum because aluminum is so soft and porous. Think of aluminum like a sponge. When you expose aluminum to grease or oil, it absorbs it. And those contaminants are going to cause you problems with your welding. And That's why even when I do my best effort to clean stuff up with aluminum, I still have issues with contamination, because there's a certain amount of that you're just not going to get out of there. And another thing I'm going to mention is, I've gone over it before on the channel. I posted a special video about not using brake clean anytime that you're cleaning something that you're going to weld. That is extremely dangerous. There's a gas that can be formed when you clean something with brake clean and then arc weld on it. There's a gas that can be formed that is absolutely poisonous. But to take that one step further and just share my opinion, I have seen virtually no benefit whatsoever to using any kind of a liquid wipe cleaner at all with welding, even with welding aluminum. Now, maybe for your application, you got really brand new aluminum, you're going to TIG weld it, it's super smooth and pristine, and you want to wipe it off with acetone. It's perfectly fine to do that. It is not dangerous to wipe that off with acetone and then weld it. But I'm not going to do that. None of the aluminum that I've ever welded on and wiped with acetone do I think I got one bit of benefit from it. And the bulk of the aluminum that I weld is not pristine, smooth. I repair old stuff. And when I repair new stuff, I have no reason to wipe it with acetone. I use sanding pads on aluminum, I use stainless steel wire brushes, and I use stainless steel power brushes. And when I power brush and sand that aluminum, it welds great. It welds as good as I can weld it. You know, maybe you're a better aluminum welder than me, and the acetone somehow gives you a benefit. But no acetone, no WD-40, no brake clean, no liquid of any kind. If I start out cleaning something and I use something that's a liquid, like I did on this rig, I start out with my power washer maybe, or some Simple Green and a water hose and a scrub brush maybe. But the acetone and brake clean, I don't use none of that stuff. If I can, as clean as I can get it by power brushing it with a stainless steel wire brush, if I can't get that in there, you know, maybe the carbide burr, at sometimes sanding with a sanding pad, I put beeswax on my sanding pads, get them turning, just touch them quick with the beeswax. That makes them sand aluminum absolutely great. It's the best trick ever for that. But just to mention, you know, that I don't use any liquid, nothing. Don't need it. Moving on. What I had right there, the tube going towards the back was the one that was broke. And it got re-welded. The other part in the front here, it was not broke. The strange thing there that I did when I got done, even though I'd welded the tube that broke, I decided to put that steel plate that they had up there, I decided to put it back. Even though I welded up where it was broke, you know, they put that on there because it was all they could do to keep it from getting any worse. But that steel plate's not hurting anything, screwed on up under there. And I went and got some little bit better screws than what they had on it, and I put it back. So, I don't know. On these other spots, you know, there's a place right there where it was broke, and they had an angle iron bracket bolted on there to hold it. And of course I did away with that, but I had the opportunity, plenty of places there to add aluminum bracing and weld it. And I think the way they had the angle iron bolted on that post, it was making the post weaker, because they had like big old bolts, not just screws, but big old bolts through the aluminum tubing. And actually I ended up welding several of them holes shut because the hole makes the tubing weaker. You know, when you drill that big hole, you're removing aluminum. So it'd be undesirable to put the steel back on there and have them big holes in it. But on that one with the screws there, I put it back. It might be a bad call, but I don't know. I think it's the right thing to do. It ain't hurting nothing. And those screw holes are small enough, I don't think they're hurting the tubing. This is the underside of where I repaired earlier. Can't get enough light on it to really show you, but it's broke. I'm going to want to weld that up. Got that welded up, and I've got a lot of stuff to put away. Final thoughts here. I got to say that ARCCAPTAIN MIG 200 did an absolutely great job here. The spool gun on there, the fact that this machine's so light and easy to move around. A lot of guys, you know, that I know, they've got an old tombstone stick welder. They've got, you know, maybe a Hobart or some kind of a MIG welder, wire welder that they got at Tractor Supply or something. The ARCCAPTAIN MIG 200 replaces all of those. If you want to know more about that machine as far as stick welding with it, flux core, MIG welding, I've already done reviews. You can go back. Actually, I'll put links in the description to 2 of the reviews that I've done on the ARCCAPTAIN MIG 200. This is the first time I think that I've actually done a major job, aluminum job, with the aluminum spool gun, and it did absolutely great. It comes with an 030 and an 040 drive roll that you flip over. I was running the 035 wire, ER 4043 grade 035 wire, and I used the 030 setup on the drive roll, and that worked great. I think I tried it with the 040 and it slipped a little more, so I went with the 030 and that worked great. Some of the things, you know, I'd mentioned before about welding aluminum, how, you know, people use acetone in the liquid, and I talked about how I don't use any of that stuff. I use a stainless steel wire brush and sanding pads and things like that, and that's all I use. Another thing that's come up that I talked about some with the guys, you know, the guys that work for the company that own this service rig. You know, a lot of times you'll have occasions where guys will say, oh, that broke, they didn't weld it good, you know. I tell you what, with aluminum it's tough. Especially, sometimes people use aluminum where they really shouldn't. I don't know if there's really a place on a rig of any sort for aluminum. You know, maybe the valve covers or something, but aluminum, you know, the tensile strength of mild steel is 65,000 pounds per square inch. The tensile strength of the aluminum that we buy when we buy aluminum sheet and tube is 34,000 pounds per square inch. Now, if we talk about weight, 1 square foot at a 1/4 inch thickness of steel is 10.2 pounds. In aluminum, that's 3.4 pounds. So even though aluminum is 1/3 the weight, it's half the tensile strength. So that always needs to be factored in. In some cases, you don't gain much. If weight isn't some major accumulative factor, in a lot of cases, you don't gain a lot going with aluminum. And the aluminum is so much more difficult to work with and repair and modify. Sometimes it's not worth it. Another really bad thing about aluminum, when we weld steel, when I weld mild steel, this steel right here, this 1/2 inch steel plate, this 3-inch channel, you know, the square tubing that we get, that steel that I'm talking about that has a tensile strength of 65,000 pounds per square inch, we weld that, when we weld that with an ER70 S6 MIG wire, that's a 70,000 pound tensile strength wire. When we weld that with a 7018 welding rod, that's a 70,000 pound tensile strength rod. So when we weld steel, it's conceivable that we're welding it with a material that's better than the base metal. That's not the case with aluminum. The aluminum tubing and sheet and aluminum angle, when we buy it, that's got a tensile strength of 34,000 pounds per square inch. When you go and you buy, I love this wire. This is a Lincoln Super Glaze 4043 MIG wire. This is a high quality wire. The tensile strength of this wire is 27,000 pounds. The yield strength is 18,000 pounds. This wire, some of the best MIG wire that I can buy to weld aluminum, is not as strong as the aluminum. And then there's other factors with aluminum in the way that, you know, it work hardens, and it needs to be annealed and softened, and there's just a lot with aluminum it doesn't lend itself to modification and welding as good as steel does. Plus, you know, the people say, well, can't you just weld that? Just weld over it. You know, sometimes with steel, dirty, greasy, filthy, rusty steel, yeah, you can just weld over it with steel. You can burn out a lot of contaminants. You can't do that with aluminum. Aluminum has to be clean, clean, clean. You can't weld through, you can't burn through any trash whatsoever. If you take off welding on severely contaminated, dirty aluminum, nothing positive will happen. You're just melting junk and nothing positive is happening. So aluminum is, you know, it's a complicated critter. Now, I am an ARCCAPTAIN affiliate. I will have a description in the link of this video, and there'll be a link in the description of this video and a lot of my videos where it'll give you a link that you can click on that'll take you to the ARCCAPTAIN website, where if you go on there and you buy a welder, I'll get credit for it. If you do that, if you want to use my promo code, you use the link in the description of this video to take you to the ARCCAPTAIN site. And when you go to buy something, use the promo code NBS Welding 5%. If you do that, you'll get 5% off your purchase. You'll also get a free gift from ARCCAPTAIN for being an NBS Welding viewer, and I'll get credit for it. You know, so that supports the channel and helps me to continue to produce content. Now, I think we've got this pretty much wrapped up, and I want to thank y'all for watching, and remember to learn to work with what you got. That way you always have everything you need. Hey y'all, we're coming to you from the break room here at NBS Weld, and I want to show you the t-shirts we got. The NBS Welding t-shirts got NBS Welding on the front, American flag on the sleeve, great big NBS Welding here on the back. Helps the channel if you buy a t-shirt. If you're interested in a t-shirt, send Tina an email request, nbswelding@aol.com. Thank you.